Welcome to practical patterns for Kotlin coroutines in production. Or maybe anti-patterns. I will show both of them, what to do and what not to do. This presentation is highly overloaded with knowledge. That is my fault. I got diagnosed with addiction from teaching people. That is terminal. And I'm coping with that by providing workshops and also writing books about Kotlin, including the most popular book about Kotlin, I believe, that is called, most popular book about Kotlin Coroutines, that is called Kotlin Coroutines. Welcome everyone in here. So let's get started. We'll start from a simple but important pattern, synchronous and asynchronous calls. So I hope you have some sense already that suspending functions are synchronous by their nature, meaning that if you make one suspending function call and another, the first one it happens, once it's finished, another one starts. And that's by rule. It's because suspend functions are not coroutines. Suspend functions are just functions that can suspend a coroutine. And if you want to introduce asynchronicity, the simplest way to do that is to use async. Async needs a scope, so wrap it all with coroutine scope and await results with await. Pretty simple. And yet, I constantly see different mistakes relating to this simple pattern. I'm especially disappointed when people do something like that. They do async and immediately await. I hope you understand it's not right and why making something asynchronous if you immediately await its result. So that's not right. If you can solve it by starting all asyncs in one place and awaiting them all afterwards. This await can be inlined in use. You don't need to create another variable. Just the point is that asyncs together, awaits together. You can use as many asyncs as you want. You can even create them in some collection processing functions like map async, and await all afterwards is a popular idiom. However, I rarely use it nowadays, as you can define this simple function that is doing it for you, map async, which is in coroutine scope, calling map async await all. Pretty simple yet useful in many modern applications. Not all, but many. Now let's talk about some other common problems and common misuses. I want you to understand, because clearly many people do not understand it in this world, is that whenever you create a coroutine with lunch or async, this coroutine becomes a children of the scope. Yeah? And one of the rules of this relationship is that parent waits for its children. And since coroutine scope is a suspending coroutine, yeah, it is suspending until it is completed, coroutine scope awaits the completion of this lunch. Okay? So coroutine scope cannot complete before this lunch is completed. So this is a nonsense. This is a mistake. I mean, you could remove this lunch from here, and the result would be exactly the same. Yeah, you're starting lunch, and you immediately await its completion. Yeah? So that's a common mistake. Remember, coroutine scope awaits for its children. So pretty often calling lunch inside of it has little sense. If you want it asynchronous, you need to start it in some other scope. Yeah? Some event scope, application scope on Android pretty often, or view model scope in view models. Nevertheless, then this lunch is a children of this other scope, and this other scope needs to wait for its children. The coroutine scope do not need to worry about it. What is this event scope? Well, that's typically something that is injected. I will show that in a moment. But first I want to summarize those two patterns in general. I started from the slide, synchronous and asynchronous. That's only half truth. The async calls in the second case are asynchronous, but the whole function, you might say, is synchronous as it awaits its body completion. Yeah, so internal get profile and get friends calls are asynchronous, but the whole function awaits the completion of its coroutines, which is a slightly different mode than starting something on external scope. Like, compare pretty quickly those two functions. The first one uses coroutine scope, it's a suspend function, and it launches different coroutines. And because of that, this function awaits those coroutines completion. And the second one is a regular function and starts coroutines on the external scope, okay? There are a couple of differences in regard to cancellation and exception handling, but in regard to awaiting, if sending email takes 1 second and there are 100 emails, then the first function should take around 1 second, yeah? And the second function should take around 0 seconds, yeah? That's the key idea. Where does the scope come from? As I told you, it's typically injected in this or the other way by our dependency injection framework. And in Android, it is typically an application scope that is associated to our application. And you know, when it should be canceled is a different story, but it also has some cancellation rules. I mentioned this cancellation a few times already, so let's move to the whole section of cancellation. This is place where especially Android developers make plenty of mistakes, so we'll primarily discuss what not to do in here. But there are two core concepts that you need to understand from cancellation. The first concept is absolutely essential for Android developers. Whenever we have a scope, this scope is associated to something, and it is cancelled when this something is cancelled. Yeah, like viewModel scope is cancelled when the viewModel is destroyed. Application scope, well, there are different implementations on different purposes. We cancel them, and of course, lifecycle scope when the lifecycle is destroyed. And what happens when it is cancelled? When the scope is cancelled, this cancellation propagates to all its children, and you know, no children in here. And the rule of cancelled coroutine is that inside cancelled coroutine you cannot make any new children, and if you are suspended, you are immediately resumed with exception. What exception? Cancellation exception. So long story short, all suspending functions throw cancellation exception. This cancellation exception is quite essential for this mechanism. This exception helps us reach the end of the coroutine while still cleaning up. Yeah, there are some things in finally that needs to be invoked. That's why coroutine is not killed. It is cancelled with exception so that cleanup takes place. That's one of the essential mechanisms of Kotlin Coroutines. And everything is perfectly fine until we start messing with this mechanism. The second essential mechanism of cancellation, the use case that cancellation was designed for, is the situation where you have, you know, coroutine scope and async await. The question is, what happens when you have an exception on one async call? What happens to the other async call? Yeah, and in other languages like C#, JavaScript, the other would still run until it will discover it's useless. Yeah, but Kotlin Coroutines creators wanted to make it better. That's why they introduced structured concurrency, and that's why the exception propagates to parent, and parent cancels all the other children. And this is an essential mechanism. This way we save our memory, we save our resources. This exception then is, of course, thrown like a regular exception and can be caught. Then it's, you know, not cancellation exception, the exception that originally broke async. So those are two essential mechanisms. Now, what can go wrong with that? The first thing I want to cover is a situation where you want to start asynchronous processes that are independent from each other. Like, consider this case, we have a list of actions that we want to launch in different coroutines, and what happens in one of these notify analytics is having an exception, okay? According to what we just discussed, you know, the rules that made perfect sense for the previous case, in this case, this rule maybe doesn't make so much sense because an exception in one notify analytics will cancel all the other. So if you want to make coroutines independent inside suspending functions, if you want an exception on one of them to not cancel the other, we need to use this magic function called supervisor scope. It's just using supervisor job instead of regular job inside of it. And this way, it is ignoring children exceptions, something to be remembered. Another problematic thing is what if you have many things like blocking or CPU intensive that are not suspending. As we said, the cancellation works when we have suspension point, yeah? And suspension point, an exception is thrown, only then cancellation can happen. Imagine here, while CPU intensive operation 1 was invoked, the scope got cancelled, the CPU intensive operations got cancelled. However, our function wouldn't know about it until it executes CPU intensive operation 2 and 3. Why? Because there is no suspension in between, no place to throw cancellation exception. And that's why in such situations, when we have non-suspending functions that are making different things, especially blocking or CPU intensive, but time-consuming things, we divide them with yield. Not a common case in Android, but this does happen in bigger projects. You can find at least a couple of such functions. The third problematic situation is what if you need to make a suspending call inside some cleanup function. As I told you already, when you cancel a coroutine, coroutine is in the canceling state, and in canceling state you cannot suspend. Every suspension results with cancellation exception. Yeah? So this means that this request database cleanup wouldn't be executed if this coroutine is cancelled, which is, well, not good. This is probably what we should execute. And for such cases, there is a special structure with context non-cancelable. That's what we use if we want to call a suspending function in a cleanup function, in the situation of cancellation. Yeah? We want to persist cancellation. And the last important thing I want you to know, maybe you will not remember them all as it's a lot of knowledge, but you can always get back to these slides later. So the last important thing I want you to know is that whenever you catch exceptions, like generally exceptions, and you are not rethrowing them, then you are messing with cancellation mechanisms, yeah, because cancellation mechanisms are based on a cancellation exception. So this is something that shouldn't happen. This is a problem that I found in at least a couple of projects as a consultant, and that can lead to very strange situations. It's hard to show them. I would require to show you a lot of code to explain what can it lead to, but it can lead to very strange consequences. And so, long story short, whenever you catch all exceptions in general, just remember to separately catch cancellation exception and rethrow it. This one shouldn't be caught. Don't catch this one. This is part of our coroutine machinery. Okay, so these are probably the most common mistakes. Now I want to move to some toolbox functions that you might find useful in your projects. I hope you won't need this particular set of functions, because this set of functions is not needed if you have appropriate libraries that are supporting suspension and flow. Yeah, if you do, you need nothing. Okay, you just use retrofit, room, use libraries that have proper suspension. No problem whatsoever. Those patterns that I will show you are not needed at all. However, if you need to call a callback API, which is, well, not uncommon in Android. Walking around the presentation, I could see many presentations suggesting to use some callback API from Android or from other libraries. If you need to use it and you want to turn it into a suspending API, that's the pattern. Get back to that slide if you have such situation. You need to suspend cancelable coroutine and set up the callback in a way that when there is a success, you resume it with the result. In exception, either some other result like null or failure, or you resume with exception, which is the same as throwing exception from the suspension point. You should also remember to invoke on cancellation, which is called when the coroutine is cancelled, to also cancel the callback. Yeah, like it should be cancelled. It shouldn't be used if we don't need it anymore. Why wasting resources? If you need to use a callback function that that produces more than one value, then you should create a flow instead. So this is the pattern. You should use a callback flow, and you create a callback in case of value, tries and blocking because it's a non-suspending context. In the error, you cancel with exception. In completion, you either cancel or close the channel. You register callback, and you should always remember to await close in the end. That's necessary. And remember to unregister the callback if this callback is not needed anymore, so when the coroutine is completed or cancelled. On the other hand, you might also need to use a blocking API. That is less common in Android nowadays, but still sometimes happens. The most popular blocking API is, of course, operating on files. If you are not using a library that is supporting suspension, if you are using native library, the native Java library, then you have blocking calls. And as you probably know, you should always wrap such calls with context dispatchers IO so that you do not block threads on suspending functions, because this thread on suspend functions is pretty often dispatcher's main, sometimes dispatcher's default. Nevertheless, both of them shouldn't be blocked. When you want to block threads, always wrap your function with context dispatcher IO. That is a probably good enough suggestion for you. However, it's not a good suggestion for library creators and for big applications. Why? Because dispatchers IO has one limit for the whole application. This limit is 64, so it's probably enough for most applications. However, I've seen situations when one repository or service just blocked all the threads from dispatchers IO, and others needed to wait in queue with probably more priority processes. So it is considered a good practice, especially for Android creators, to create dispatchers with custom limit. Yeah? Dispatchers IO limited parallelism is a way to create a dispatcher which is reusing the same threads as dispatchers IO, but it is having an independent limit, so they will never fight for limit. Yeah? On Android, this number limited parallelism can be small, like 5, or it can be bigger, like 50. It depends on what are your priorities. Now, something that people talk less often in Android, which is synchronizing coroutines. First of all, whenever you operate on multiple threads, you need to make sure that you have no conflicts. There are many tools for synchronizing our applications. However, for Kotlin Coroutines, the simplest rule and also the safest and the simplest and quite efficient one is to just create a dispatcher with parallelism limited to 1. When there can be only one thread operating on those functions, there are no conflicts. So we have a situation where we have no problems. Give me a second. Thank you. I will need to request a bigger room from the conference because it's the third year in the row in this conference where people do not have seats on my presentation. Thank you. Okay, and there are things that are probably more interesting for Android developers, which is making one coroutine await for another. That is something that we especially often do in ViewModel scope. If you want one coroutine to await until a different coroutine is completed, the safest way to do that, the simplest and the safest way to do that is to just collect the job of this first coroutine and join it. Yeah, job, join is just like async await. The only difference is that await returns value, join doesn't return value. That's the only difference, okay? They are both suspending until the coroutine is completed. And once the coroutine is completed, they are doing nothing, just immediately resuming. Another tool that I find useful for synchronizing coroutines, it's also useful in some tests, but in all the layers you can find it useful, oh, sorry, that's not what I wanted to say. Here I wanted to say that you can also have just collection of jobs. Sorry. Another tool that you might find useful is completable deferred. Completable deferred is like a box for a value. You can use it to complete it with value, so to put a value inside, and you can use it to await value. Yeah? There can be only one value inside, and the value stays forever once you complete it. So it's just a way for one coroutine to await for something. One particularly popular situation for this pattern is a little bit more complicated, but I will help you with this marks. This is one popular implementation of an MVI pattern, and the problem that people consulted me with was that when they had one coroutine observing all the events, and they had different coroutines that were sending to this shared flow. Yeah? And the problem was that sometimes some coroutines sent events before shared flow, before the coroutine observing on the shared flow was ready. Yeah? So some events could be lost. So if the sending happened before the subscriber, no one actually received it. There are a few ways how this can be solved. It can be solved with a channel that it has, a buffer. It can be solved with a reply. However, from different cases, other solutions were not satisfactory for this project, and so we ended up making this very simple mechanism where we just create a completable deferred that helps us await until subscriber is ready. On subscription, the deferred value complete notifies that the subscriber is ready, and on the event side we join, which means await until this event happens. That's one way how we can synchronize coroutines. Okay, and the last section, it went pretty fast. The last section I wanted to cover is a few patterns around flow, and I want to make it clear how what should be the most idiomatic way for using flow. Generally speaking, flow it was introduced to represent more than one value. Yes, so a situation when you have a WebSocket or AirSocket, a situation when you create an observer and a database, like more than one value. For one value, the most idiomatic approach is, of course, to use a suspend function. That's the default approach for producing or fetching value and returning it. Of course, I know many of you are using flow for single value, and it also has its advantages. I'm just saying what the library was originally designed for. Nevertheless, I need you to understand that flow is called, and whenever you collect on a flow, let's say you have this observe message, and whenever you collect on that, you create a new observer. Yeah, you start a new AirSocket or WebSocket connection, or a new observer on a database, which is pretty often problematic. We don't want to have more WebSocket connections than they needed. They are very limited and quite expensive. And one pattern that I often introduce as an optimization is to use shared flow. Share in. As you know, shared flow is like a broadcast channel, is like a subject. So you can take one flow and share it in a variable. And notice that this locations must be a variable, because otherwise it would be created a new one for every call. It must be stored in a variable. And here we pretty often use the option started while subscribed, meaning that the connection will be opened when the first listener appears and will be closed once the last listener disappears. Okay, that's a pretty popular optimization when we operate on flows that start some observers on databases or on network. And the last one is particularly designed for Android developers. I had a couple of conversations about it recently. The difference between shared flow and state flow. Do you know what's the difference between them? There are actually a couple of differences. Like generally speaking, Stateflow is a lot like shared flow. It even implements the same interface. But first of all, it is conflated, meaning that some updates can be lost. Second of all, it is only emitting value when the value change. Yeah, if the value is the same, it's not emitting the value. And third of all, it always must have value. So long story short, Stateflow is perfect for representing state. So representing something that has, where you are not interested, for instance, in the intermediate state. Like, what does it mean conflated? It means that if the listener is too slow and the values are produced too fast, the listener might not receive all the updates, which is perfect for a state. Yes, if for instance, imagine that you have a listener which is updating a view and a emitter that is very quickly making one update in the view and then another. And do you want to force it to first display the intermediate state and then the final one, or you just want it to print the final one? Of course, the final one. That's why Stateflow is perfect for our view model usages when we want to represent state. However, all the situations where we have things that, where the intermediate values are important, like errors that we want to display, like messages, like notifications, like all the situations where we don't want to lose intermediate value, or when it makes sense to display the same value if it's the same as before, so like unit, all those situations should be represented with a shared flow. Yeah, so state we represent with a state flow. All the progress bars, something to be displayed. Most of the things on Android, but things that are kind of like events to receive, like errors, like dialog messages or some post messages should be rather represented with shared flow. This is what those two were designed for. More in the book and in the workshop. There is an open edition soon. And I will publish slides from on Twitter, I guess tomorrow, and there will be a quiz for you in a moment. But before that, thank you for your attention. Okay. Now, I have enough time for giving a quiz. I have 4 books, but I left in a speaker room. So those people I will tell that you will receive a book, will receive it. They just need to go with me to a speaker room. But the rules of the quiz are simple. I will show you some code snippets, and your task is to tell me what are the mistakes in here. And you probably should be next to the microphone if you're ambitious, because I don't know how the microphone goes. I know there is one in here. Probably it's the only one. Okay. So that's a simple code, but yet there are at least a couple of mistakes in here. They were all discussed in the presentation. Maybe I can make it a bit bigger. So tell me, what's wrong with that? I mean, what can be improved? Yes, and what should we do? Oh.
Yes, so we should rethrow the cancellation exception.
Yes, that's one. So stay with me afterwards. Of course, cancellation exception should be treated specially, and we shouldn't silence it like all the other. Okay. What's up with suspend function? Calculate signature. I assume it is happening on CPU, not on. So it's not supposed to be suspending function. Sorry, there was someone. Dispatchers IO. What should be in dispatchers? Around what? Well, we could use that. I will. I will say it's right, but I would actually wrap only that. I mean, it wouldn't be it wouldn't be a mistake to wrap everything with dispatchers IO, as it wouldn't hurt us to do other things on dispatchers IO. But sorry, not cancel before the delete. It will be called anyway. Okay, you already have the book, so let others speak up. I don't know. You probably should use mic, but okay. Just be first. Sorry, I don't know who, but you be first to answer. You can speak it up if you are allowed. Yes, I mean yes and no. So I will accept that. Because it was an intended thing to do. So before the change, we should use yield in here. Right now, actually, we don't need to use yield in here because with context is a suspending function. So in this particular case, we don't need to use it. However, if we had it like suggested initially, then we would need to use it. Yeah? So then we would need to use yield here so that there is a space for the mistake. Okay, there are some other suggestions. Sorry, he was having a hand. Go on. Yeah. Sorry. On the file. Oh yes, this one also should be, but I won't count it because yes, this one should also be with IO. Exactly, but we all have everything on IO, so I won't count it because we have everything in IO.
Finally should be with context, no cancelable.
No, I mean, that's a nice catch, but finally is non-suspending. So it doesn't need to be in with cancelable. Okay, your silence is perfectly right. Because that's all the mistakes I found in here. I hope that some of you will suggest to me to use async await, which would be wrong. Okay, go on. Yes, of course, inject the dispatchers, but again, that's a simplification. Yeah, we inject dispatchers because of testability. Okay, so that on test we can replace them. Oh, Wojtek.
Marcin, I have a question. Is there a reason you're using yield or catching the cancellation exception instead of using ensure active?
It's more or less the same. And I mean, in this case, it's the same. Ensure active is an extension on a scope. Yield is a suspending functions. It's just our convenience which one do we use. In long story short, they should work the same in such cases. In the cases of blocking operations, though, we prefer to use yield because yield is also redispatching. So, you know, giving the thread back to the pool and then taking it again so that you are going to the end of the queue. So with blocking operations, it's nice to do that to not starve other threads. Sorry, but I truly believe that's all in here. I have another one in a moment.
I just have a question. Will file delete be executed on the dispatcher's IO threads?
Right now, yes, because it is wrapping everything.
Okay, so even though it's not suspending?
Yeah, because this coroutine is executed on dispatcher's IO. Okay, one thing I hoped you will incorrectly give me as an answer is to use async await, which would be a nonsense because it's clearly a sequence of operations, and so async await would be no improvement at all in here. Okay, another piece of code, but probably that one is the simple one after what you covered already. So I will not count this one, but what's wrong in here? Yeah, we are not catching a cancellation exception. I wanted to show it to you. You can get back to that later. I hope it's also recorded because this particular case, in case of cancellation, is an infinite loop without catching cancellation exception. So this is one of the fun mistakes that led to quite a serious consequences. Yeah, because if this is a suspending call, this throws cancellation exception, then we catch and print it, and then we do that again. And it is infinitively doing catching and throwing and catching, which is quite a nonsense. Okay, and this is a, probably some of you saw that, but I have last book to give away. So who first will tell me what's wrong in here? So, sorry, let's try to find something that wasn't in the previous one. Async await. No. Ha. Async await doesn't make sense in this case as well, because to do that, we need to have that. To do that, we need to have that. This is a synchronous process. Async await, I intentionally designed it this way. Makes no sense. Okay, go on. Exactly, so you will take the last book because it's something that wasn't on the previous one, and this clearly should be with context, context non-cancelable. Okay, do you see anything else in here? There are 3 more problems. One is, of course, dispatchers IO. Let's make it fast, so 2 more things. Yield, of course. And what else? This is actually an idiomatic way to make operation in case of cancellation, but there is something missing in here. Rethrowing cancellation, of course. After that, we need to throw this cancellation exception because the function that called update user might be interested in catching or handling that as well. Yeah, particularly coroutine might be interesting in receiving it. So, we should always rethrow cancellation exception. We have 4 people. I hope you remember who those were, and there will be no fights in here. I technically finished my time. However, as I told you, I'm addicted for teaching, so I'm not keeping anyone in here. But for the others, I will be answering questions until the organizers bring me out of the stage by force.